Alright, let's go. Number 10, the cold spot that shouldn't exist. In 2004, astronomer Patricio Vielva and his team at the University of Cantabria were analyzing data from NASA's Wilkinson microwave anisotropy probe when they discovered something that defied every model of cosmology we had built. In a region of the sky near the constellation Eridanus, the cosmic microwave background radiation, the afterglow of the Big Bang itself, was significantly colder than it should be. The anomaly spans approximately 1.8 billion light-years across, making it one of the largest structures ever identified in the observable universe. The cold spot shouldn't exist. Standard cosmological models predict the universe's background temperature should be almost perfectly uniform, varying by only tiny fractions of a degree in any direction. Yet here was a region colder than surrounding space by a margin so extreme that the probability of it occurring through random fluctuation is less than 1 in a billion. Scientists initially assumed it must be a measurement error. Follow-up observations by the Planck satellite confirmed it was real. But here's where conventional physics collapses. In 2015, astronomer Istvan Sapudi proposed a disturbing explanation. The cold spot might be evidence of a collision, a cosmic bruise left behind when our universe struck something else during its inflationary phase. According to this theory, our universe isn't alone. It exists within a larger structure called the multiverse, and at some point in its early history, it brushed against another universe entirely. The implications are staggering. That other universe would operate under its own laws of physics, its own fundamental constants, its own version of reality. The collision left a permanent scar on our cosmic background, a wound in space-time that we can still observe 13.8 billion years later. And if one collision happened once, nothing prevents another. Somewhere in the infinite dark beyond our universe's edge, other realities drift through the greater void, and one of them has already touched us. Number 9, the dark flow. In 2008, astrophysicist Alexander Kashlinsky at NASA's Goddard Space Flight Center announced a discovery that sent shockwaves through cosmology. By analyzing the motion of galaxy clusters using data from the Wilkinson microwave anisotropy probe, his team detected something impossible. Approximately 1,400 galaxy clusters were all moving in the same direction at speeds exceeding 600 kilometers per second, drifting toward a specific point in the sky near the constellations Centaurus and Hydra. This collective motion has a name now, dark flow, and nothing within our universe can explain it. The mass distribution we can observe doesn't produce enough gravitational pull to account for the movement. The galaxies aren't being attracted by anything inside our observable cosmos. They're being pulled toward something outside it, something beyond the 46 billion light-year boundary of everything we can see. What makes this discovery particularly unsettling is what it implies about the geometry of reality. The universe we observe might be a small bubble within a vastly larger structure, beyond our cosmic horizon, yet past the boundary where light has had time to reach us since the Big Bang, something massive exists. Something so enormous that its gravitational influence reaches across unimaginable distances to tug on thousands of galaxy clusters simultaneously. Some theorists propose the attractor is another universe entirely. Others suggest it might be a remnant from the inflationary epoch, a region of space that expanded differently than our own. The most disturbing possibility is that we cannot know. The object pulling our galaxies lies permanently beyond observation. Its nature will remain hidden forever because the expansion of space itself prevents light from that region from ever reaching us. We can feel its presence. We cannot see its face. Number 8, the bubble collision evidence. In 2010, physicist Stephen Feeney at University College London led a team searching the cosmic microwave background for something specific. If the theory of eternal inflation is correct, our universe is one of countless bubbles forming in a vast inflating multiverse, and occasionally these bubbles should collide. Such collisions would leave distinctive circular patterns in the cosmic microwave background, scars from contact with neighboring realities. Feeney's team found 4 candidate signatures, 4 circular patterns in the cosmic microwave background that matched predictions for bubble universe collisions. The statistical significance was debated, and later analyses by the Planck satellite team disputed the findings. But the mathematical framework remains sound. If eternal inflation is correct, and most cosmologists believe some version of it is, then our universe has neighbors, and we have already touched them. What makes this scenario particularly disturbing is what it means for the structure of existence. In the eternal inflation model proposed by physicist Alan Guth and developed by Andre Linde, the process that created our universe never stopped. New universes are being born constantly, bubbling into existence from the inflating substrate. Our universe is 13.8 billion years old. The greater multiverse might be infinitely older and infinitely larger, with new realities emerging every moment. Each bubble universe has its own physical laws. In some, gravity might be repulsive. In others, time might flow in multiple directions. In still others, consciousness itself might be impossible, or alternatively, consciousness might be the fundamental substrate of reality. When bubbles collide, the physics at the interface becomes undefined, regions where competing realities attempt to overwrite each other. The truly unsettling implication is that our universe might be surrounded by these collision zones, our cosmic horizon pressed against realities we cannot comprehend. Beyond the edge of observation, our universe's laws may already be breaking down as they encounter neighboring bubbles. We exist in a finite pocket of coherent physics, and the walls are thinner than we know. Number 7. The hidden variables beyond space-time. In 1964, physicist John Bell proved something that should have been impossible. His theorem demonstrated that quantum mechanics is fundamentally non-local, meaning that entangled particles affect each other instantaneously across any distance, violating the speed limit of light itself. Einstein called this spooky action at a distance and refused to accept it. Decades of experiments have proven Bell right and Einstein wrong. But the implications of Bell's theorem extend far beyond quantum strangeness. If information travels between entangled particles instantaneously, it must travel through some medium. Space-time itself forbids faster-than-light communication. This means the connection between entangled particles exists somewhere outside the space-time we inhabit. There is a layer of reality beneath or beyond our own where distance and time do not apply. Physicist David Bohm proposed the concept of the implicate order, a deeper level of reality from which the universe we observe emerges. In this framework, everything we perceive as separate objects and distinct moments is actually a projection from a unified underlying reality. The three-dimensional world of space and time is the surface layer. Beneath it lies something else, something that connects all things instantaneously and has no geographic structure we can map. What makes this scenario particularly disturbing is its philosophical weight. If a deeper reality exists beneath space-time, then our entire experience of the universe might be a shadow of something more fundamental. We perceive objects separated by distance, events separated by time, but these separations might be illusions projected from a realm where all things are simultaneously present. The hidden layer would be inaccessible to direct observation. No instrument can measure it because all instruments operate within space-time, yet it influences every quantum interaction that has ever occurred in the history of the universe. Every atom in your body is entangled with particles across the cosmos, connected through a substrate of reality that exists permanently outside our perception. You are not where you think you are. You are not when you think you are. The coordinates of your existence are projections from somewhere else entirely. Number 6. The holographic boundary. In 1997, theoretical physicist Juan Maldacena at Princeton published a paper that fundamentally changed how physicists understand reality. His work demonstrated a mathematical equivalence between a theory of gravity in a certain space and a theory without gravity on that space's boundary. The implication was staggering. Three-dimensional reality, including the gravity we experience, might be equivalent to information encoded on a two-dimensional surface surrounding the universe. This is the holographic principle, and it suggests that everything we perceive as three-dimensional, the depth of space, the volume of objects, the expansion of the cosmos itself, might be a projection from a two-dimensional boundary we cannot access. The universe might literally be a hologram, with all the information describing reality encoded on a distant surface and projected inward to create the illusion of depth. What makes this theory particularly unsettling is what lies on that boundary. The surface encoding our reality would exist outside the universe as we understand it. It would have dimensions and properties our three-dimensional minds cannot properly comprehend. The laws of physics as we know them would be emergent phenomena arising from information processing on this higher structure. Some physicists have extended this framework into what they call the holographic multiverse. In this model, our holographic boundary might be one of many, each projecting its own universe inward. The boundaries themselves might interact in ways that shape the universes they generate. Our reality could be influenced by neighboring holograms we will never perceive, patterns on adjacent surfaces bleeding through to alter physical constants on our side. The truly disturbing implication is the nature of observation. If we exist as projections from a two-dimensional surface, then the mind experiencing this thought is also a projection. Your consciousness, your memories, your sense of self, all of it might be encoded on a boundary you can never see, processed by a substrate you cannot comprehend. The universe isn't just strange, it's not even really here. Number 5. The conformal cyclic cosmology evidence. In 2010, mathematical physicist Roger Penrose, who would later win the Nobel Prize in 2020, proposed a radical theory about the nature of reality. He called it conformal cyclic cosmology, and it suggests that our universe is not a singular event, but the latest in an infinite sequence of universes, each one emerging from the death of its predecessor. Even more unsettling, Penrose claimed we could see evidence of previous universes in our cosmic microwave background. His theory proposes that as a universe ages and all matter decays into photons, the concept of scale loses meaning. An empty universe of pure radiation becomes mathematically equivalent to the infinitely dense point that begins a new Big Bang. The old universe doesn't end, it becomes the starting condition for the next one. Each cosmic cycle leaves traces in the next, and Penrose believes he found them. Working with astrophysicist Vahe Gurzadian, Penrose analyzed the cosmic microwave background and identified concentric circles of unusually low temperature variation. He interpreted these as evidence of massive black hole collisions in a previous universe. Their gravitational wave signatures somehow transmitted across the boundary between cosmic cycles. The interpretation remains controversial, but the mathematical framework is taken seriously by physicists worldwide. What makes this theory particularly haunting is its implications for existence itself. If conformal cyclic cosmology is correct, then the universe has no true beginning and no true end. It extends infinitely into the past through countless previous cycles, and it will extend infinitely into the future through countless cycles yet to come. Everything that has happened in our universe has happened before in slightly different forms, and it will happen again. The truly nightmarish aspect is what this means for individual existence. If each cycle produces a universe with similar physical laws, and if those laws permit consciousness to arise, then versions of you have existed across countless previous cycles. Each one lived, suffered, and died, leaving no trace except perhaps faint patterns in a cosmic background they could never perceive. The universe outside our own isn't just a parallel reality. It's every reality that ever was, stretching backward through infinite time, each cycle forgotten by the next. Number 4, the many worlds branching structure. In 1957, physicist Hugh Everett III completed his doctoral thesis at Princeton under the supervision of John Wheeler. His work proposed an interpretation of quantum mechanics so disturbing that it was largely ignored for decades. Everett suggested that every quantum measurement causes the universe to split into multiple branches, with every possible outcome occurring in a different version of reality. His theory is now called the many worlds interpretation, and it has gained significant support among modern physicists. The implications extend far beyond abstract physics. If the many worlds interpretation is correct, then the universe you inhabit is one branch among an uncountable infinity. Every decision you have ever made, every random event that has ever occurred, created new branches where different outcomes played out. Somewhere in the vast tree of reality, there are versions of you who made different choices, versions of you who never existed, and versions of you who died yesterday. What makes this structure particularly disturbing is what it suggests about the space outside our universe. The branches do not exist elsewhere in our cosmos. They exist in a higher dimensional structure that contains all possible quantum histories simultaneously. This structure is called the multiverse of many worlds, and it dwarfs our observable universe by factors beyond comprehension. For every second that passes, uncountable new branches spawn into existence. Physicist David Deutsch at Oxford University has argued that the many-world structure must be real because quantum computers, which are being built right now, rely on calculations that only make sense if parallel branches exist. When a quantum computer solves a problem, it is effectively drawing on computational resources from neighboring universes. Every time one of these machines operates, it provides evidence for the existence of realities outside our own. The truly unsettling aspect is what lies between the branches. The structure connecting all possible quantum histories has its own geometry, its own architecture, its own properties. It must, because something must distinguish one branch from another and prevent them from collapsing into chaos. Whatever that connecting substrate is, it exists outside any universe we can observe, and it contains everything that ever was or could be, all at once. Number 3, the thermodynamic arrow beyond our cosmos. In 1927, British astronomer Arthur Eddington coined the phrase, the arrow of time, to describe why time flows in only one direction. His insight connected the forward motion of time to the second law of thermodynamics, which states that entropy, the measure of disorder in a system, always increases. Time moves forward because the universe moves toward greater disorder, and the two are mathematically inseparable. But here is where our understanding breaks down. The second law of thermodynamics requires a starting point of extremely low entropy, a state of improbably high order at the beginning of our universe. Nothing in physics explains why the Big Bang started in such a special configuration. For the universe to behave as we observe, something must have set its initial conditions with extraordinary precision, conditions so rare that their occurrence through random chance is effectively impossible. Physicist Sean Carroll at the California Institute of Technology has proposed a disturbing explanation. Our universe's low-entropy beginning might be the result of a process occurring in a larger structure outside it. In this framework, our cosmos emerged from a higher dimensional reality where entropy behaves differently. The arrow of time we experience is a local phenomenon. That's a consequence of conditions imposed from outside. What makes this theory particularly haunting is what it implies about the greater reality. If our universe sits within a larger structure that generates low-entropy regions, then that structure must have its own thermodynamics, its own arrow of time, its own history, and the timescales involved would dwarf the age of our universe by amounts that defy imagination. Our 13.8 billion years might be a single tick in a clock measuring trillions of years. The truly nightmarish implication is the inevitable end. Eventually, our universe will reach maximum entropy, a state called the heat death, where no energy gradients remain and no processes can occur. Time itself will effectively stop because nothing will change. But outside our universe, the greater structure continues. It will spawn new low-entropy regions, new universes with their own arrows of time, long after our reality has faded into eternal stillness. We are a brief, bright spark in a darkness that extends beyond comprehension in every direction. Number 2. The mathematical universe hypothesis. In 1998, physicist Max Tegmark at the Massachusetts Institute of Technology proposed an idea that pushes the boundaries of what science can even investigate. He called it the mathematical universe hypothesis, and it suggests that our physical reality is not merely described by mathematics. It is mathematics. Every physical structure that exists is a mathematical structure, and every mathematical structure that can exist does exist as its own universe. The implications are vertiginous. Tegmark proposed 4 levels of multiverse, with his 4th level being the most extreme. At this level, every possible mathematical structure corresponds to a physical universe. Universes with different numbers of spatial dimensions exist. Universes with completely different physical laws exist. Universes where the fundamental equations of reality bear no resemblance to ours exist. All of them are real in exactly the same sense that our universe is real. What makes this theory particularly disturbing is how it redefines existence itself. If the mathematical universe hypothesis is correct, then the question of why our universe exists rather than nothing has a strange answer. Nothing doesn't exist as a mathematical structure. Only somethings can exist, because mathematics only describes structures, never their absence. The universe has to exist because it must. So does every other universe. The framework also implies that somewhere in the mathematical multiverse, every conceivable reality plays out. There are universes governed by logic we cannot comprehend. Universes where consciousness takes forms we cannot imagine. Universes where the basic concept of existence means something radically different. All of them are as real as the chair you're sitting in. Our cosmos is one point in a landscape of infinite mathematical possibility. The truly unsettling implication is what it means for your own existence. You are a mathematical structure. Your consciousness, your memories, your sense of being a continuous self, all of it is pattern and relation. And every mathematical variant of you also exists. Versions of you with different memories, different lives, different personalities. All of them are equally real in their own mathematical universes. You are not one being. You are an infinite family of beings scattered across a landscape of pure structure, and most of them are strangers to the one reading these words. Number 1. The Brane collision theory and the origin of everything. In 1999, physicist Lisa Randall at Harvard University and Raman Sundram at Johns Hopkins proposed a theory that would reshape the foundations of cosmology. Their work, drawn from string theory and M-theory, suggested that our universe might exist as a 3-dimensional membrane called a brane, floating in a higher dimensional space. Beyond our brane, other branes exist, other universes occupying the same greater structure, and sometimes the branes collide. The theory was extended by physicists Paul Steinhardt at Princeton and Neil Turok at Cambridge into what they called the ekpyrotic model. In their framework, the Big Bang was not the beginning of everything. It was the result of 2 branes colliding in the higher dimensional space. The tremendous energy released when our brane struck another created the hot, dense state that expanded into our universe. Our entire cosmos began as a bruise from contact with another reality. What makes this theory particularly terrifying is its prediction of repetition. If our universe began from a brane collision, nothing prevents another collision from occurring. the branes exist in a higher space, moving according to dynamics we cannot directly observe. Another impact could happen tomorrow, or a trillion years from now, or at any moment in between. When it does, our universe ends instantly. A new Big Bang overwrites everything that exists, rewriting reality from its first moment. The higher dimensional space containing the branes has a name in theoretical physics. It is called the bulk. The bulk has its own geometry, its own laws, its own structure. We cannot access it because we are confined to our three-dimensional brane the way a drawing on paper cannot leave the page. But the bulk influences us constantly. Gravity itself might be a force that leaks between branes, which is why gravity is so weak compared to the other fundamental forces. Gravity is the one thing that isn't fully trapped on our sheet of reality. The truly nightmarish implication is what this means for existence. If other branes exist parallel to our own, separated by tiny distances in the higher dimensional bulk, then other universes are not far away in space. They are inches away in a direction we cannot perceive. Right next to you, closer than the walls of the room you are in, other realities play out their histories. Civilizations rise and fall in universes separated from ours by a dimension we have no words for. And one day, one of them will drift too close. When the collision comes, there will be no warning, no chance to understand what is happening. Our universe will simply end, and something new will take its place, unaware that we ever existed. If you want to see more videos like this, click the video on screen now and make sure to subscribe.